All right, good afternoon, everyone. My name is Patrick Sun. I am the Managing Director of the National Operations Center of Excellence, and we wanted to welcome you to our webinar today. We're going to be talking about connecting our work zones or connected work zones and how mapping a work zone and the tool chains that are available are going, and some of the lessons learned, but at the same time, some of the things that we might need from the community. We're really thankful that you're joining us on this Friday afternoon. And if you don't know, just a reminder, the National Operations Center of Excellence, NOCO, we exist to transfer knowledge about the TSMO resources and the TSMO practice, TSMO being Transportation Systems Management Operations, and that practice. And we do that through the sharing of resources, supporting the TSMO community, and all these resources are available online 24/7 on our website, and you can just go there to our website at transportationops.org, or any of the links that you see in the top right box that you have. And if you subscribe to our newsletter, then you'll get major TSMO announcements that are going on around in this country, and all the things that are being done in our practice. And so as we get started, I just wanted to go through a few housekeeping items. For this and every webinar, we record the webinar and put the recording available on our on-demand learning section and in other places on our website within about a week. So if you have any questions about, where will be the recording be, just go back to our website or subscribe to our newsletter and you'll get a notification. During the webinar, all the participant phone lines are muted, and any questions that you might have or even comments, please use this question discussion pod here, and you'll see me type and go through there. We will do a Q&A session at the end of the webinar after all the presenters have had a time to speak. And so we encourage you to be able to ask any question. The speakers are quite knowledgeable. And with that, I'm going to go ahead and ask Dean to get us started and really talk about, as you see on the agenda here, what are the infrastructure systems that we're looking at for work zones. And as we go through the different speakers, we'll be able to give you a lot of their in-depth knowledge about connected work zones. So Dean?
Hi everyone, this is Dean Dieter, and as Patrick said, my role today is to orientate you to the topic area that we'll be presenting on today and give you some context and some background into it. How I'm going to do that is by talking about two connected infrastructure systems, connected work zones and connected signalized intersections. Now the focus of today's webinar will be on connected work zones, and you'll hear a lot more about some resources. We're going to introduce two resources today: the model concept of operations, and the software tool chain. The software tool chain being the majority of the emphasis of today's webinar. But I also just wanted a reminder, many of you might have participated in webinars that were put on by NOCO related to connected signalized intersections. There's several of those that have been recorded. They're available on the NOCO website. There's a large number of resources available regarding connected signalized intersections. There's the SPAT challenge model concept of operations, the SPAT challenge model requirements, SPAT challenge verification document, and there's also BDI map creation tools, just a sample of the resources that are available. As you can see, there's more resources available for signalized intersections, and we're hoping to build that up for the work zone. So this webinar today is a crucial part in helping us to grow those resources. So as I mentioned, there is a model concept of operations. It's titled Infrastructure Systems to Support the Reduced Speed Zone Warning Lane Closure Application. It's intended to be a model concept of operations to encourage a systems engineering approach to state and local DOTs who are deploying connected systems. The idea is that as you build your own local concept of operations and or requirements, you could use this as a resource to help you. The focus of the document is on the infrastructure systems to support onboard applications. There's no focus on the onboard applications themselves, other than they are a user of the infrastructure systems. So as it steps through the infrastructure system, it talks about the current situation that many DOTs operate, the stakeholders that would be involved with a connected system, the stakeholders' needs, and then the operational concepts for the proposed infrastructure systems. So for those DOTs looking to develop the infrastructure side, of the reduced speed zone warning and lane closures that could support work zones, but also other things such as reduced speeds around school zones and things such as that. These would be your operational concepts for those, and it steps through several scenarios for those operations. The document is communications medium agnostic. There's a quote from there. It cites some of the examples of what it would support, or DSRC, cellular V2X, cloud-based communications, or a combination of these. With reduced speed zone warnings or work zone warnings, a lot of times the latency isn't as important. So there's already some examples where a lot of those informations are being communicated through cloud-based approaches and things such as that. So this document is available now. You can download it at the CAT Coalition website, which is on the transportationops.org. You can see the link there. Resources is a tab on the CAT Coalition site, and it's one of the top 3 resources in the table there, and you can download it, and we hope that it brings value. So part of the model concept of operations is it goes into some scenarios for providing location data as the infrastructure owners and operators build these connected systems. And it introduces a high-fidelity work zone map data, something that if the infrastructure owners and operators have the resources, they would provide detailed lane-specific data describing each lane through the zone. Could get into lane configurations, tapers, things like that. Also, workers' presence in the zone status could be included as part of that high-fidelity work zone map data, and you'll hear more discussion about that from each of our speakers today. It also introduces low-fidelity work zone map data, probably that's more familiar to the DOTs, something that's analogous to what's already done today with travel information systems. That's a little higher level description of the work zone. It may describe right lane closed, it may describe reduced lanes, a start point and an end point, or maybe just a zone. But the idea there is that is something that is easier to pull together. So as you read the concept of operations and it describes the high-fidelity work zone map data, it goes into some detail about just how complicated that could become. And today you'll see a tool that hopefully makes that easier to create and to develop. So that's really my introduction to what we're going to do today. What you'll see after this is you'll hear from Todd Peterson, FHWA, about how this relates to the work zone data initiative that FHWA has going on. You'll then hear some background on the software tool chain from Jay Parikh, who's involved in creating it. He'll tell you how you can access it, how you can use it, and give you more details about it. And then you're going to hear from 2 sites that have actually used the software tool chain, and you're going to hear speakers talk about how they've used it, their lessons learned with that. And then we'll come back with kind of our request to the industry to use and test the tool chain. So that concludes my introduction. So with that, I will turn it over to Todd Peterson from FHWA.
Great, thank you, Dean. So my name is Todd Peterson. I'm with Federal Highway's Work Zone Management Team with the Office of Operations. And for about the past couple of years, I've been the project manager for the Work Zone Data Initiative project that we're leading. And today I'm going to explain about how that relates to the Work Zone Mapping Toolchain. So the background for the Work Zone Data Initiative, just to give you some understanding of that, is it's a broadly focused initiative to look at work zone management. It acknowledges the perspective that work zone management as a practice is increasingly data-driven. Information on where and when the work zones are occurring is increasingly important to just being able to do the basic job of managing work zone activity, managing getting traffic through the work zones, managing work zone safety. It's just some sort of those bread and butter issues that transportation agencies deal with on a day-to-day basis is increasingly more reliant on good quality data. So the more we thought about this, we have been considering this in our own efforts and wanted to sort of build a project around elevating the state of the practice in terms of work zone data. And what we came to realize is that there's some types of data that's nice to have for some applications, but you start to think of some of these emerging technologies like connected and automated vehicles, information, good quality, high resolution detailed data on work zone physical layouts is crucial to being able to do something like navigate an automated vehicle through it. So there's degrees of dependency on good data. So that was the objective of this project, was to consider this broad spectrum of potential uses for the data and try to encapsulate that into a national practice that allows us to be able to share open data in a consistent format to really break down those jurisdictional boundaries and boundaries between information systems, break down the silos between just interdepartmental silos and silos between the agencies themselves and our external stakeholders. So just having more open, more shareable data, more consistent, really is going to allow us to sort of scale up the activities that we're doing and bring value to the efforts that are made to build tools around that. So that was really the motivation behind this project. So the strategy we're focusing on as part of this project is two things really. One is understanding what the data looks like. What is the specification for it? If you were going to build a computer program about work zone activity data, what does that look like? And the second is understanding the system frameworks that describe agency business processes, stakeholder business processes for how all this information is actually used. So we took a four-step process to look at this project. We did a state of the practice review, which conducted a synthesis of sorts of what people are using information on work zone activity for, and what would they be using work zone activity data for if they had better data. So we wanted to look ahead a little bit, look beyond what the current practice is, and think about what's the potential for this if we had better data. And that was all served as an input into a framework document which described the systems that support all these different use cases and the uses of the data themselves. Built a data dictionary that described, based on the use cases in that framework, what pieces of information are required to support those use cases. So we had those three foundational pieces, and based on that, we're proceeding with some pilot deployments with participating states to actually put these principles into practice, sort of a learn by doing type thing, take the documents, take this first stab at what this world of consistent work zone data looks like and put it into practice, with the ultimate goal being that the participating agencies are all contributing to what's known as the Work Zone Data Exchange, which is sort of the implementation of the Work Zone Data Initiative product is really this consistent feed which everybody is sharing. Everybody that's publishing to this feed is sharing the same data. All this data can talk with each other. So if you have the capability to work with Work Zone Data Exchange, you can work with data coming from a variety of sources, so that provides a lot of power. So that's the objective here, is to kind of encourage everybody to start looking at the systems and the data requirements, kind of develop a deployment around those principles, and move towards publishing the data in that consistent format. So the thoughts that went into developing the framework and the data specifications, we took into consideration how work zone activity data kind of migrates through the project lifecycle. You think about what is work zone activity data by itself. Really, it's that record of what's actually happening on the ground. It's where's the work zone occurring? How long is it going to be there? Is there a speed limit reduction? It's that full picture of what's actually happening with the work zone itself, and we'll talk a little bit more about those categories here in a bit. But what goes into that depends on what stage of the project you're in. At a planning stage, you're looking at estimated work zone activity. You don't have a clear understanding of what's happening, when a specific lane is going to be closed. But generally, so there's potential applications for that in terms of project coordination, predicting impacts, being able to do some advanced trip planning. But when you put that first cone down, we actually go to construction. As soon as there's actually activity on the ground, that's when the data becomes real time. You want to have a record of what's actually happening out there. So that's real data. That's work zone activity data that's happening, and it's this phase at which we really see the clear implementation for the work zone data mapping tool. Because when you get that work zone on the ground, you want to know what it looks like. You want to be able to communicate what's happening to drivers that are navigating that work zone, whether it's a human driver or an automated vehicle. Is it a shoulder closure? Is it is it 2-lane closures? Is there a speed reduction? All these elements of the work zone itself need to be communicated upstream. So, there's some pretty clear real-time applications for this, and then when that last cone goes up, anything that was real-time data at one point becomes very valuable post-construction data for other uses, analytics, other type of analysis that you might want to go back and look at what actually happened during construction. So there's this huge universe of potential use cases to look at for this. So to make the project a little easier to digest, we broke it down into use case categories, and these 7 categories basically summarize the issues we just described in terms of the the life cycle of work zones and how the data kind of changes through time and what some of the applications are. And what we see is that there's a large potential overlap with the work zone software toolchain. It covers 5 of these categories are potential applications for the output of the software toolchain. So that I think this is a very valuable tool in terms of being able to serve some of these use cases. So getting back to the work zone activity data itself, this diagram describes the overall data concept model, and I'm not going to go through all of this, but I'd like to direct your attention to the box on the sort of the middle left, about the one labeled project event with a dotted line around it. If you think about a work zone project, you're going to have multiple phases. You might have multiple closures associated with a single phase. You might have a mainline closure and a ramp closure, for example, they're part of the same phase, but they're separate. Each of those, obviously, you would want to account for in getting that information out to drivers. Each of those closures is an element of work zone activity data. So the tool chain obviously feeds that, and it provides a mechanism to feed what's called the work zone lane activity data frame that describes what that closure looks like. Are we talking about a shoulder closure, or lane closures, or what? And that the idea is that work zone lane activity data frame, it's adaptable, and it could be low fidelity data that's referring to lane closures via linear referencing system, or it could be very high resolution data such as you might get from the work zone mapping tool. So the work zone data initiative data dictionary provides that extensibility to say, depending on what type of data the agency is able to generate, you can upgrade the quality and detail of your data by changing how that information is defined within those data frames. This is yet another complicated diagram which describes the overall system framework that we described before, where we tried to look at all the various interactions of how agencies work with the data, how it's generated, how it's put into use, what's the interplay between these different business processes on the agency side. So we took a look at these and looked at what are some of the primary areas of overlap with the work zone mapping toolchain. And the primary role of the toolchain is really just to serve that data generation piece. So if you're thinking about it from the standpoint of what kind of hardware and components would be out there, it's your smart work zone components, your connected and automated vehicles being the resources that are driving the generation of that information through agency interfaces back to this broader agency work zone data system, which can then be used to serve other use cases such as helping state and local DOTs assemble details of the work zone, just for the sake of management, being able to manage the work zone. It can create a georeference to the data that provides different details about the work zone to support additional traveler information mechanisms. And again, the traveler information that can be a human driver, it could be a connected automated vehicle, and depending on what you're collecting out in the field, the information that is conveyed through a traveler information system is augmented by what your mapping toolchain is picking up. Finally, there's important supporting role here for the software toolchain in understanding changes to implement in future work zones. If you're getting good detailed information about what the physical layout of your work zone is, and you're able to correlate that with performance measures such as traffic delay or safety metrics, that gives you a very powerful tool to go back and make what-if decisions about operational strategies or safety strategies that allow you to sort of learn, to engage in that process of continuous improvement to try something, measure how well it worked, and go back and improve on that the next time. So just to summarize, the work zone mapping toolchain is some good applications for this. Again, primarily it's providing a mechanism to create that detailed high-fidelity work zone geometry for inclusion in the work zone data exchange feeds. The potential applications for that, including the validation of the work zone physical elements. If you're generating that information from the field, it gives you a tool to be able to verify what's actually happening out there. If you're in the role of managing a work zone, you can see what's going on. You can, if a cone falls down or a sign's not installed properly, you can see that. So there's clear applications for both maintaining the work zone, inspecting the work zone. Is the contractor doing what they're supposed to do? Did they set it up the way they were supposed to set it up? A lot of potential applications there. The next is augmenting the traveler information by facilitating the navigation of work zones by connected and automated vehicles. With that detailed information, you're finally able to reliably run an automated vehicle through a work zone, which you can't really do with just a linear referencing system unless you're heavily reliant on the onboard navigational systems of the vehicle itself. Third, the identification of variations from approved work zone geometry. I mean, if something changes that's not picked up or entered properly into the system, conducting the mapping toolchain process will provide that information to validate the information that's being provided to drivers through traveler information systems and whatever. So that's an important step of the validation process to vet and make sure that data that's being provided is authoritative. And finally, the clear application of having that data is being able to maintain that record of detailed work zone geometry for forensics or analysis into the future. So that's hopefully an informative overview of the Work Zone Data Initiative, and obviously a lot of ground to cover beyond this, but I hope that provided a good connection point to the Work Zone Mapping Toolchain and how that fits into all this. And with that, I'm going to turn this over to Jay Parikh at CAMP to further discuss this. Thank you. Jay?
Hey, thank you, Todd, and thank you, everyone. Hi, this is Jay Parikh from CAMP. I am the PI for the safety applications for vehicle infrastructure. So under that application development, we developed this particularly based on our past experience that a long work zone can be 10, 12 miles long. It will be very difficult to how do you map it. So I'll talk about the toolchain. So with that, so if you look at from the infrastructure map requirement for connected vehicle applications, you could define that in 3 different categories, like a low fidelity, which is kind of defines a region, which just very broadly indicates which region has some issues surrounding it. A little bit of medium fidelity could talk about the road level. That says this particular road has lane closures coming up and or diversions of some kind or so. And the high fidelity is what I will be focusing on, which is the toolchain, which provides a lane level detail, including the lane closures, so where the lane closures takes place, lane open up, speed changes, also, the map also provides information when the lane is closed, what are the alternate lanes the vehicle can go to, using something called connects to definitions also. So why do we need that? And what do we need? In order to a proper accurate infrastructure maps is crucial for V2I applications. And when I talk about V2I applications, it's more on a basis of kind of a context sensitive, meaning that if I'm driving on a lane that is close ahead, I would like to inform the driver that that lane is close ahead. However, if the lane is, if the driver is on the lane that is not closed, I don't need to bother him about telling him that there's a lane closed, and I don't need to warn him about that. Similarly, if the driver is going above the speed limit, posted speed limit within the work zone area or where the worker is present as such, only then I need to inform or alert the driver. There is no need otherwise to provide those information as a generic. So this has led us into development of high resolution mapping tool. And this also allows for the agencies to create a map in a consistent manner so that application, the intended application on the vehicle side of it have an intended outcome and does not provide any anomalies. So map zone, I mean, this is just a simple example of connected work zones. And what do we need from an application point of view on the vehicle side of it? So it's we need to know where the start of the work zone is. We call it a reference point. Layout of each lane, where the lane closures are, or the lane opens. A closed lane can open multiple places also. In case of this diagram here on the right-hand side, the current layout of the configuration is changed such that the lanes are going towards to a island and connects to the opposite side of the lane. So this is a very complex design in terms of the mapping part of it. How would you map something that is of that nature? And also needs to provide enough detail to the driver so that the driver is aware of what's going on. So the one way to do all these things is to have a survey or use Google or Bing map or satellite view and select the node points as we have done it in the past. But that is a very long and cumbersome process. Also, surveying the area also takes time and costly because the configuration keeps on changing. Another reason for developing this toolchain was that from a vehicle perspective, vehicle needs to know its position based on the lat long position as also from the map data. And if the map data are defined in such a way that you have those node points are far apart from each other, on a curvature area that a map matching algorithm would have a difficulty and may not be able to produce the right positioning information for determining which lane the vehicle is on. Primarily because on the curvature, as you can see, that a rectangle bounding box may fall outside of this curvature, and the map matching algorithm thinks that it is outside of not the current lane, but it's the adjoining lane, and so forth. So this application that or the toolchain that we develop it dynamically adjusts those parameters as it sees the curvature on the road, and it automatically adjusts those node points such that it optimizes to the level that the map matching algorithm works as intended and is highly successful. So with that, what does the software toolchain consist of? Software toolchain consists of 6 different modules, starting with the first module, which is called vehicle path collection data. In this case, what happens is that you are collecting a vehicle path. You drive an instrumented vehicle. In this particular case, instrumented vehicle consisting of a GPS receiver, and in our case, we used U-blocks, and the software, which is part of the software toolchain, which allows you to collect the data as you are driving through an open lane throughout the work zone, and you need to drive through that lane only one time. it collects the data at 10 hertz. So very high resolution data is collected. From that input, it converts a map as required and defined in the J2735 SAE standards. So that is the technique it uses to do that. So once you collect the data, and once you define what are the configuration of the roadway looks like, meaning it is how many number of lanes are there and so forth, what are the speed limits at different locations and so forth, and those two pieces of information then builds a map in XML format. And that XML format map, it becomes an input also to two different things. One is it also parallelly generates a visualizer. This visualizer is whatever the map that you drove to collect the data, as well as the software that generated XML map. They're all overlaid on a Google map, so you visually can see what you've developed, what the tool has generated out of. So that gives you a visual verification of how the map is, what the map looks like. That piece of information from XML now becomes an input to a map message builder tool. What we have developed as a message builder tool is that it generates an UPER encoded message as defined in the SAE standards, and that UPER encoded message becomes a RSU agnostic, a message that's ready for you to transmit for the connected vehicle. So that is the whole set of things that is shown in this diagram. Oops, why did it disappear?
I'm not sure. Let me get that back for you, Jay.
Did you?
Yeah, that was a little bit. Sorry about that, everyone. I'm just gonna double check correct name.
Okay. I think we're back now.
Anywhere around.
Yes.
Right here.
Yes. And okay, good. Thank you. So, as I mentioned, it's made up of several components, and the output of the complete toolchain is a UPER encoded message that's ready for transmission by other RSU, or you can even use it for cellular communications. However, we have tested everything using RSU at this point using the SRC technique. To that message, then you can add the IEEE protocol and security requirements such, and now that message is ready for transmission. So let me go through all the components that are built in this work zone map builder. As you would be able to see, and on the left-hand side, as you see here, that a work zone consisting of total 4 lanes. Lane number 2 is open throughout the work zone, and 3 lanes are closed in different locations. So the first step actually one can do is to collect the data by driving through the open lane. And in that case, what it does is the purple dots that you see are the dots that's been vehicle path data. Those data points are collected at a 10 hertz, so very high resolution. At the time of driving, you also mark the areas where the lane process are started and closed. And also the locations where the workers are present, so it marks the workers present zone and so forth. That information becomes an input to the second part of this toolchain, in which you define how many lanes there are in the work zone, what are the speed limits associated with the work zone. This one also allows you to indicate time of the day or the week or the month that this work zone activity is inactive. So that means it provides you kind of a time when which this message should be transmitted and is effective during the work zone activity. The third step is that once you build those two things, which is the data collection and the configuration, then with this section of the tool builds the map for you. So you provide what's the name of the configuration file is, and it generates the map for that. The generated map then can be viewed using called Map Visualizer. Map Visualizer takes the data that you collected and the map that you built, and it overlays on a Google satellite view. In this case, it's hard to see, but you can see those original data points, plus the icons that indicate where the node points are generated out of this map, including if there are worker presence and so forth. It will also include those as an icon. So this gives you a visual verification of what the map looks like. And the last step, once it is all verified, the last step is that you feed that XML file which I mentioned earlier. That XML file becomes an input, and the tool called Message Builder takes that information and creates an encoded message. This makes the message of the map message itself as agnostic from any kind of RSU. It is something that can be ready to transmit. So these are the components of the software toolchain that allows you to start from mapping a work zone using it, just driving through a work zone lane, all the way to an encoded message as a map builder. What we have as a part of this toolchain is all developed using Microsoft Windows, and most of the applications are done using a Python. And several components are part of this whole toolchain. In addition to that, the toolchain is available for download, and it also consists of a user input, user guide that guides you step by step how to use the toolchain, and also provides you all the examples and things that you need to use this toolchain. That's pretty much what I have for my presentation. With that, I would like to transfer that to Bob Bridia.
Thanks, Jay. Morning, everybody. My name is Bob Bridia with the Texas A&M Transportation Institute, and you just heard Jay give a great overview of the actual mapping software, the toolchain. So I'd like to talk to you a little bit about one implementation that actually started to test that aspect of what we were doing. I'd like to point out that the project that we were doing here has several partners, including CAMP, TxDOT, USDOT, and Southwest Research Institute, and we appreciate the opportunity today to present to you. So in terms of this project, what we were trying to do was we were trying to overall test the reduced speed zone warning lane closure mapping process and OBU application from CAMP. So the pretty colored blocks over here on the right-hand side are very, very high-level task listings of what we needed to do. Because it was such a large project and so many folks involved, we really had to establish some really good working agency relationships. We started that off with the multi-agency site visit back in March of 2018. Sat around for a couple days, really got into details about things, and that helped us establish an ongoing technical process that was in place for the entire length of the project. We also looked at different approaches to the information needs, and I'll get into that a little bit. Ultimately, we wound up with a field deployment and prototype testing, and then that gave us a lot of great information and lessons learned to bring into the national guidelines that CAMP was charged with preparing as part of their work effort under USDOT. So just to familiarize you with the area that we were talking about, we're on the I-35 corridor between the major cities of Austin and Dallas. We centered our work zone activity right here in Temple. This entire section of roadway from Hillsborough to Salado has been under construction for several years. Here's some aspects of the construction efforts, again, just for some background. I'll just call your attention to the fact that volumes can vary significantly along this pathway. In Temple, they're typically around 80,000 ADT. And although we're estimated to complete 2019, we're currently working in the section in Waco. Contractors are currently working in the section in Waco, and so our estimated time of completion is now somewhere in the 2023 timeframe. In terms of the overall connected work zone and what was done, obviously TxDOT owns the roadways. We came in, and as part of the support efforts that we're doing to assist the Texas Department of Transportation, we have a very high resolution, or I should say a detailed lane closure database of all the lane closures that exist. And when I get to lessons learned and next steps, I'll relate this back to the efforts that Todd talked about with the Work Zone Data Initiative. CAMP came in and provided a wonderful mechanism to digitally map the roadway. We are working, we then implemented, the connected vehicle equipment, the DSRC radios, and those types of things on the roadside. And TxDOT, using the software from Southwest Research Institute, has a statewide traffic management software, which was integral to the approach of what we are trying to do in terms of disseminating information and making this an automated process that can transfer across the entire state. That's something to keep in mind as we go through this information here. So obviously there's some challenges to what everybody is trying to do here. In Texas in particular, work zones are not set up and left in place on interstates. Work zones are set up at night, and then they have to be torn down by the morning commute. So in a couple-mile long work zone, you can be setting up and taking down in the same place every night, or you could be setting up and taking down in many different places every night, different directions, different mile markers throughout the entire length of things. It provides a challenge to being able to consistently, map exactly what's going on there. And particularly if, say, a traffic shift occurs, your mapping that you did the day before no longer is valid for the day, once the shift is in place. Other challenges are, we know that the state of equipment and specifications in this arena are still evolving. I think it's completely fair to say, not going to name names obviously of vendors, but different vendors have different levels of adherence to specifications, different capabilities, and we certainly ran into that into the project. And overall software solutions for accessing those types of, those pieces of equipment and the mechanisms that you need to do to configure it and to upload files and everything, those are also very different across different vendors. And then we really have to consider different information levels, what's available versus what's desired, what's an ultimate versus what can you do now. And ultimately we need to recognize that not all of the IOOs out there can support a level of information need or desire that is consistent across the nation. So I had this in here just in case Jay didn't have it in his slide presentation. Obviously, that's the toolchain mapping software. Jay covered that quite well, so I don't really need to go through any of that. I will say that what we came up with when we were doing our initial agency, multi-agency visit is we very quickly saw the need to go to separate the information need into what we call the high fidelity and the low fidelity approach. Now, Jay used some of that same terminology. It's a little bit different in what we're talking about, and I'm going to go through that in the next slide or two. But what we wanted to do is we're taking our work zone information. We have a high fidelity approach to communicating work zone information to vehicles that can receive that, a low fidelity approach, tested both of those, and then brought that information back together as the overall input into the national guidance. So what does it mean when we say a high fidelity and a low fidelity scenario? And I think what I'll do is I'm just going to skip ahead to this a little bit more detailed slide. So on a high fidelity, what you're trying to do is you are trying to provide lane level guidance to the driver. So for example, if it's a two-lane section of roadway and the right lane is closed, as you're driving up the roadway and you're in the right lane, you're going to get a message that says what you should do related to the lane closure. If you're in the left lane, you will not get a message. Now, that is a decision point that different IOOs are going to have to make for themselves as to how they want their roadways to operate. That requires a full information load for the reduced speed zone lane closure application. Requires detailed lane level mapping. In the project, we were working with Camp and Denso OBU application for this, and we did a manual configuration of multiple virtual test work zones. I say they're virtual work zones because we were afforded an opportunity because we were operating in a construction zone and essentially no connected vehicles were out there to be able to receive this information except the ones that we had. You know, we weren't necessarily tied to only driving through the work zone at night when it was actually taking place. We could create virtual work zones, send out the information, broadcast it, and drive through and do multiple testing scenarios within the same day. It required the full RSM message, and the important thing to key on here is that at this level, there was no system-level integration to the statewide software Lone Star. That's an important component because if you look down at the lower fidelity message and the fact that TxDOT wants to make this a systemic methodology across the entire state, but they're not at the point where they can support the full work zone information load. We did a basic RSM message and an automatic upload from Lone Star to the roadside units, and that was done all through the statewide software. So essentially, we took the work zone mapping, the digital mapping from the work zone software toolchain from CAMP, digitally mapped the work zone. We took the lane closure database that we have of all of the information across those 200 directional miles and where things are. We married them together, internal to the statewide traffic management software, created the capability to automatically generate the RSM messages and to send those RSM messages out onto the roadway for broadcast. In terms of the actual field test, just a quick picture here. This is Temple. This is South Loop 363 to North Loop 363. So we covered about an 8-mile stretch with 9 RSUs. We've often heard, I think, that RSUs typically can only broadcast, let's say, 300 to 500 meters. We were actually getting broadcast ranges of approximately a mile. We did many different closure scenarios, multiple lanes, multiple closures, alternate lanes. Jay showed some of the different configurations that are possible within the mapping toolchain to test, and we started from crawling and just doing a single closure in a 2-lane section in the right lane to trying to do some of these more complicated scenarios. This one just shows the overlap of some of the RSU broadcast, so the extent of the DSRCs, and this actually shows the low fidelity application, OBU application that we were using from Southwest Research, because again, CAMP had the high fidelity OBU application and Southwest Research had the low fidelity OBU application. Sample testing results, don't worry about the table on the right. It's there just to show you that, this stuff works. And then these are some of the different scenarios. So you see a single lane closure, a lane closure that tiered down onto multiple lanes, and just different types of scenarios that we were able to go through and test. Now let's get to the really important stuff, the lessons learned. I think it's very easy to say as a lesson learned that we know that the work zone setup differs by state and region. I think we can fairly definitively say that the software toolchain, the mapping, and the applications work. We've proved that. We do know that hardware suffers from inconsistency, lack of standardization, those types of things. And I think it's important to note that integration of lane closure information is in its early stages. Now again, one very important aspect of what we were trying to do here on the low fidelity side of that is to again achieve that marriage and figure out the right methodology for that. So we're trying to take that lane closure information, marry it up with the digitally mapped representation of the road, create those RSM messages, and send information out automatically. That requires a very large set of linkages or relationships between multiple agencies. And each individual IOO is going to eventually have to chart that appropriate path and what level of information they want to support. In terms of that linkages, who's all involved? Well, depends on the state, but you definitely need information from the contractor as far as the lane closure data, the appropriate level of detail, all of those types of things. Depending on the state, some states require pre-approval by the state agency for lane closures. Other states say that folks are pre-approved to go out there and do those lane closures. All of that relates to the level of information that you can get out of that. You need to integrate the work zone mapping and the closures. Again, we tried to do that in a very systemic process. We did find out that because of the 10 hertz, 10 times per second data collection from the software toolchain, in order to do that at the lower level of fidelity, we actually had to throw out a bunch of data because there was just too much data to send out. Within any IOO, there are multiple systems and endpoints, there are challenges linking all of those things together. You have the folks that maintain all the ITS devices. You have TMC operations. You have travel information. You have all of these different endpoints, and I think it's fairly common that there are different objectives and information sets in use on that. And then when you get out to the roadway itself, you've got vehicles and you've got infrastructure. The IOO and or their contractors can control the infrastructure. We have no capability to control anything that's going on with the vehicles, including the interfaces and how all of this information is ultimately going to be viewed by a driver as decided by automotive OEMs. In terms of the challenge associated with data, there's the discrepancy in the level of detail, what IOOs have versus what OEMs want. I think we all have seen that and recognized that. Lane closure information, which lanes are blocked. The CAMP software is extremely capable in that it allows you to say, I'm going into a lane closure, I'm necking down over into another lane, now workers are present, I have a reduced speed limit, I'm now coming into a section where workers aren't present, I can have a different speed limit there, and now I've necked down over into another section of a closure situation, workers are present again. It's very, very complex and allows you to do very complex types of lane closures. That'll be great for the future. In the current capabilities of what IOOs have to support in this, we're kind of at a more basic level, but it's wonderful that those things are there. And then obviously we understand that roadway geometries are changing and updating, lane shift after construction, we saw several times in Temple where we had lane shifts between the left and the right sides of the road, and then that really requires you to go through and re-digitally map everything. I'm missing a slide. Let me just tell you what's coming up next. So one of the things that we're doing next is we are going to take our lane closure data feed and we're going to transform it into the work zone data initiative format that Todd talked about. So that's kind of how that relates back. That allows us to help support FHWA and the Office of Operations in their quest for a national standardization of work zone information. We're going to continue to test the OBU application. In this case, we'll be concentrating on the low fidelity application component of it, and we're going to be building another connected work zone to test for the next couple of years in Waco with some very complex construction efforts that are taking place there, about $350 million for 6 miles. And we will be continuing to support that. We're also looking at how we can get this information into the freight community, whether that's through their electronic logger devices or and APIs that have data injection capability in that. So that's a lot of what we're going to be doing in the future. And so with that, I'd like to turn it over to Larry Head, and he can talk about his project.
Great, thanks, Bob. It's really nice to be here today to be able to share information. Okay, good, that's my presentation, I can do that one. About our project and learn about what others have done. So our project we call the Arizona Connected Vehicle Work Zone Experience is what I'm presenting about today. And this was a project that was funded under the Innovative Technology Deployment Grant Program, formerly CVision, from the Federal Motor Carrier Safety Administration. And the lead on the project was Arizona DOT and Maricopa County DOT. And one of the things that's really, I think, different about our project over what we've heard today is we were focused on developing a system for freight vehicles to notify them about what's going on in the work zones and inform them about the work zone, make them aware of an upcoming work zone, alert and warn them about things in the work zone. And do that both on arterial sections of roadway and on freeways. So I'll come back to the architecture diagram. We use the CAMP tool to build the RS road safety message. The idea, as Jay talked about with the map, we actually transformed the map data after we got the UPR encoded message into JSON for our processing and use. And so this just is a quick snippet of the header of the JSON from the road safety message, and then a Google map that we use in testing at the bottom. So we use the CAMP tool. Jay went through it. I can save time by not spending any time on that. We're really appreciative because in our project, we started before we knew about the tool, and building the maps was one of the hardest hurdles that we were addressing. So the idea in our project was that if you were a truck and you were traveling, making a trip, you might want to be informed about there's a work zone on the roadway segment that you've decided to travel. And that might give you enough information that you would take a detour. But if you decide not to take a detour and you approach the work zone, then you should be aware of the work zone coming up and then get alerts and warnings about different things that are happening. And so we wanted this to be integrated into the vehicle and the in-vehicle systems. We wanted to be able to get the information to those in-vehicle systems from either a fleet management system or even systems like, some of the popular travel applications like Google Maps and such. And then we wanted to have the infrastructure managed with the roadside units to distribute the messages throughout the work zone. So to get informed, the first thing we did is we took that JSON that we had and we gave it to Oz Engineering, who works for Maricopa County DOT, and they put it into a system called ARIES. And the ARIES system is Aztec Regional Information System. And I really, in this diagram, I'm focused on this freeway section of I-10 and these two cones that represent the start of the work zone in east and west direction. And then down here on MC85 or Buckeye, we're east and west. And then there's some early information about making the drivers aware that are on signs. And this is one of the messages from the signs. So this is the inform part. And we use the work zone data exchange. So Oz Engineering took the JSON from us, converted it into work zone data exchange, put it into the system, and used that to notify travelers. The aware part of it was us using the basic map and then a couple of different human-machine interface concepts that were there that would give the information about lane closures, workers present, and speed limit. that's there. And what we wanted to do is we developed a prototype so that we would have control over the testing and demonstration, but we also worked with this company DriveWise, who has an in-vehicle system. One of our partners was Swift Transportation, and they work closely with DriveWise to have in-vehicle systems. So these are just a blow up of those two mechanisms. We output from our system a JSON string. It's not the full JSON map. It's really just the information that you need to talk about how many lanes are there. Is the lane closed? Which lane are you in? Is there a taper coming up? How far to the taper? The look ahead distance is based upon the vehicle's current speed and the type of vehicle that it is. So heavy vehicles are treated differently than passenger vehicles. We show in our HMI prototype, we show the work zone speed limit, the actual speed of the vehicle, and I don't know who was driving the day we collected the data. Could have been me, but I wouldn't admit to that today. That's there. So, so let me tell you a little bit of our experience with the CAMP tool. I would say that it's necessary and valuable for creating these road safety messages that describe the reduced speed zone or the work zone. Some of the problems that we faced are, where's the work zone? Right? What constitutes a work zone and what do we call it? And I'll talk about that. And then lanes, where are the lanes and where did they move my lanes? As we get longer work zones, we found out that we would start off in one lane and we would get shifted in different places. And then when you do create the road safety message and you want to broadcast it out over the DSRC, it breaks the message down into different segments because of message size, and you have to reconfigure them. So one of the questions is, when do I have several segments, or when do I have several different road safety messages? So this is the AZ511 system, and I highlighted the two study areas that we had, but the part that I wanted to really highlight here is every time there's a project that's led and contracted and there's a traffic management plan, one of these icons appears in the AZ511 system. And so, you know, it looks like Phoenix is getting a famous, great work makeover here with all the different work zones. And so when we look in the I-10 work zone here, there's a 8 or 9 or 10 or a dozen different projects that are there, and each one of them is managed separately. And down here on MC85, where part of these are the Maricopa County widening, but some of them are City of Phoenix projects. And so how do we as developers know which zones and which work zones are we developing the road safety messages for? So I come back to this, and we distilled that down into these two study areas that we had for our project. And from that's where we generated the JSON, the road safety message, and the work zone exchange message. So one of the things we noticed is so I'm in Tucson and this is in Phoenix, and every time we went back to do some testing or something, they moved our work zone. Right? These things change all the time, and there's workers present and not present. And as we heard in the previous, in Bob's presentation, sometimes they do the work at night and sometimes they do it during the day. And so, you know, these are changing rapidly. And so one of the challenges that we see is keeping up with the frequency of change to keep the high fidelity map message relevant. And then lanes, where are the lanes? So if you think of driving down, and this is a couple of pictures from the arterial. If you think of driving down this arterial, it looks like it's a 2-lane arterial, and then they added a right-hand turn lane, and then they added a left lane and a right lane from 1 lane. And so where did we go from 2 lanes to 1 lane to a left turn lane to a right turn lane in channelization? And maybe these happen because we're in this arterial, and the tool was probably originally thought of mainly for freeways that's there. And then this is a case where we started off on 2 lanes going down, there were 2 lanes in the other direction, and then it was 1 lane, and then they shifted us all the way to the other side, and then they shifted us back, and they added turn lanes and things that were there. And so the concept of lanes, and in the beginning when you use the tool, you say this section has 3 lanes and I'm driving in lane number 2. Right? We can follow the signs in the traffic for that particular piece of time, but how do we do that so that we get contextually correct information? The time of day needs were mentioned, and then this whole issue about multiple messages versus multiple message segments, and what's the best way to partition it. When you do one big message with multiple segments, that's fine. The RSUs deliver those messages to you, but then you assemble those together into one road safety message that then generates the JSON that drives the application, that drives the warnings and things for the driver. Or if you break it into several different road safety messages, then you're turning on one message and off one message and on one message, and we need to figure out the best way to do that. If you have different contractors that are managing different sections of the roadway, are they then going to be responsible for each generating a road safety message? And from a driver's point of view, you want it to be smooth and connected and cohesive, but that's not the way the road construction projects go. So our next speaker is Colin Castle, although I understand Colin's not with us today. So Patrick, I think you're on to present Colin's information.
Actually, it's going to be Dean for us, as he's familiar with this. He's going to fill in for Colin, as Colin had to fill in for his director at Michigan DOT. So, Dean, why don't you kind of take us and finish us off?
Great, thanks, Patrick. Hi again, everyone. So what Colin was going to cover was a recap of some of the benefits of using the software toolchain, and I'm going to share two of those with you. The first benefit is we really see that the software toolchain can help to increase the industry's understanding of the technical and financial aspects of creating high-fidelity work zone map information. Again, it's analogous to the SPAT challenge. I think one of the success stories out of the SPAT challenge was that a lot of agencies got some hands-on experience with creating the systems to support SPAT and map broadcast, and they came to understand what it takes to take the information out of the signal controller and convert it into the messages, what it takes to create the map messages. With this project or with this initiative, the software toolchain gives you that opportunity as well. I've heard several DOTs that talk about the goal of having AV-ready work zone data or CAV-ready work zone data. This is your chance to experience what that would take to do it and how this tool can help you do that. I think it will help to increase the understanding of the likely cost to create this and to update it as work zones change, as Larry talked about, and just overall increase the industry understanding of the likely rollout of connected work zones and help the DOTs begin to understand how quickly they might have their work zones equipped with this. So that's the first benefit that I think everyone can work towards with this. The second benefit is we'd like to have feedback provided on the work zones toolchain. CAMP has developed this and it's out there. There's a recognition that it's only been used by a small number of agencies. We'd like to hear more feedback on it. They would like to hear information about that, any insight into changes or enhancements that might be needed. We also think it's an opportunity for feedback sharing with other DOTs and consultants, those that begin to grow more lessons learned, as you heard from two of them today. Those and other use cases can be shared around with other communities and really begin to understand how the software is used and the many ways the software can be used. So today's request is really to download the software if it's appropriate for your agency, experiment with it, trial it, gain familiarity with it. Remember, you don't necessarily even have to have a system where you're planning to disseminate the information. You can simply download the tool and use it to create a high-fidelity work zone information for a work zone. Ideally, you would eventually have a system to receive it and see if it was correctly formatted and could be interpreted. But a lot can be gained just by creating the high-fidelity map information. When you go to the CAMP website where you can download the information, you'll be able to see that there's an email address, info@campllc.org, where you can send your feedback to that. So that will be monitored. We'll share the information and share with the community. So again, that's the request. We'd like to have usage of the information. CAMP would love to hear feedback on it. And with that, Patrick, I think we'll open it up to the Q&A. I see there's a lot in the chat box.
Yeah, we've gotten some great, I'll call it good chat traffic during our webinar, and it just speaks to kind of the interest that we have from our community. So let's get straight into it. I'm going to do my best to kind of field the questions to the particular speakers, but I think I'm going to rely a little bit on the expertise of the speakers to speak up for, some of the messages that they might be able to answer. And so here's the first question. Do you have best practices for high fidelity map messages? Also, what is the level of effort to provide high fidelity map messages? I think this one, I'm trying to remember. It might be Bob or Todd. Either one of you want to kind of take a first stab at this one?
I'm thinking
so this
that might have been
Right.
put to Dean's in response to Dean's original presentation, but yeah, I'm going to defer to Bob on that one.
Yeah.
Yeah, so this is Bob. I'm not exactly sure what best practices for a high-fidelity map message would be. I think what the starting point for that would be best practices just for mapping your work zones in general. As Larry said, lanes, lanes, lanes. Where did my lanes go? That's a very appropriate way of putting it. Understanding where your work zone is and how it's changing tells you when you need to go out and remap everything. And I think that's the starting point of the best practices. From then, you can get more technical, so to speak, on the best practices in terms of how to do it, understanding things. One of the things that you have to watch out for is little nuances that happen in construction. For example, one time we went through and we noticed that the vehicle, when we started to overlay things, we were constantly out of the lane that we were actually traveling in, and that was because we had the software set that it was a 12-foot lane, and because it was a temporary situation for construction, the lane was actually like 14 feet. So that has to come into best practices. You have to be aware of those types of situations. But in terms of developing the best practices, that's something that I don't think anybody is at that point yet, and it's something that the community is going to have to work collaboratively on to do that.
Yeah, thank you, Bob. Let's go to the next question. How do you consolidate the traffic control plan to the actual traffic control devices used and placement? So this one, I think it'd be interesting if we got a few different perspectives on it, but someone want to try to take this first? Larry, maybe?
Yeah, Patrick, this is Larry. One of the comments I would make is that in the practice of the contractors and managing the work zone and what they're actually, they submit their plans and they get them approved, and then what they actually put out in the street, that needs to be really tightly coordinated, because the map needs to be what is actually in the roadway. And so, the best practice that evolves from our experiences really needs to capture that, and the agencies need to be able to put that requirement, I think, on the contractors perhaps that are out doing it. We can't be broadcasting a map message that doesn't match what's in the roadway, and to me that's a bit of a concern. So
yeah, and you definitely saw that a little bit more on the arterial streets. Jay, I was hoping to see if you had any perspective on this when you're looking at those really long kind of work zones that are going for miles and miles, but and how you guys have kind of looked at it from your perspective.
So Patrick, this is Jay, and one thing can be done as we were developing the mapping tool chain is that if you have arrow boards and or the barrels which already have the GPS built in, if that information can be captured to the agency and fed directly into the initial data that collected using the data for visa, and when the lane closures moves, those can be updated dynamically as the arrow boards keeps changing positions. That way you don't have to go out and remap the map, but you can do the map by just running the software toolchain, and it can generate a new map for you.
And this is Bob. I'll add one more aspect into this thought. We also need to remember that we're kind of in the very beginning of a brave new world here. Contractors do not have experiences with these types of procedures, so it's going to take quite a while, at least in my opinion, for contractors to get up to speed on having this as something that is either a new activity that they have to do as part of their project, or at least as an activity that they have to coordinate with, and those types of things. Contractors traditionally concentrate on placing concrete, and doing that, and now there's a lot more here that eventually they're going to need to be able to do and to collaborate on, and that's going to take some time.
Yeah. Todd, I was curious, you went through a pretty extensive kind of systems approach and even process approach. Did you guys kind of address this in the Work Zone Data Initiative, or how have you guys kind of started to talk about it?
Well, I think the perspective we're coming from is that, and Bob alluded to this, that we're looking at a lot of capabilities and technologies that are really going to be useful at some point down the road. But we're coming from a point that's still very centered on sort of these pen to paper type activities of how a traffic control plan manifests itself in the field, and how information might arise in the database. It's there are not systems in place to make these things automated. So we have to, as professionals, we have to be that bridge from sort of the current state of the practice to make these things happen over time, and how we implement that is going to be sort of a slow migration from not a whole lot of detail in our work zone data at all, which is what we have today, to more of a low fidelity implementation, and eventually, hopefully, to a broader deployment of the high fidelity data using techniques such as this mapping tool chain. And I see it noted down in one of the later questions that how does this address a mobile work zone? And I think challenges like that are really going to stretch our capabilities. And I'll be interested to hear somebody else's answer on whether or not the mapping tool chain can address a mobile work zone. But I know there are other platforms for data generation, such as instrumented vehicles, the instrumented autonomous maintenance technology that's being tested in Colorado and some other states comes to mind as a platform for producing live data for mobile work zones. So I think there's going to be a migration of capability over time, and it's important to keep that in mind as we go forward. Focus on what we can deploy today. Maximize those capabilities for whatever value we can get out of them, while keeping in mind that our needs and our capabilities are going to get better over time.
Yeah, and I think you brought up a good point, is that this is probably one of the more obvious examples of where we are in our industry, going from pen to paper to a full digitization. That doesn't happen overnight. I think in that particular response you gave, Todd, you actually answered the next question, which is how do you address stale data or when the work zone has changed suddenly. I think that also goes to the mobile lane closure that Pierre asked. Does the tool chain address mobile lane closures? So I'm going to kind of go to the next couple of questions. Some maybe.
Patrick?
Yeah.
Can I interrupt for 1 second? This is Bob.
Absolutely, Bob.
So going back to the mobile work zone or the mobile lane closure, I don't know what the question was actually going towards. Different IOOs consider a mobile lane closure something different. So in TxDOT, on an interstate, essentially every lane closure is a short-term mobile lane closure because it's only up there for a maximum of about 10 to 12 hours per night. That's different, obviously, than a rolling operation or something like that. So I'm not sure exactly where the intent of that particular question was, but we did make the work zone, the toolchain mapping software and the digital representation work for the Texas type of mobile work zones where it is in a different place every night.
Got it. I think, if nothing else, that question highlighted how we have variability about what we call mobile lane closure. So,
right, least, which goes back to Todd's activity on the Work Zone Data Initiative and standardizing all of that.
Yeah. Quick question: is the tool chain open source? I should know this off the top of my head, but I don't.
Yes, it is, and yes, and I think I don't remember, but DIN maybe provided the link to download the toolchain from a camp website.
Got it. Yeah, and that'll be available, and I'll make a comment about the PowerPoints. Another kind of question is, are these tools using GNSS or simply GPS?
It is using GNSS, so you can leverage a large number of satellites, and also it also supports differential corrections as a part of the U-Blox GPS receiver that we used. So yeah, it is using GNSS.
Yeah. So let me go to, and Tony, I'll get to your question last because that's kind of in my closing. And Pierre, we talked a little bit about the tool chain and addressing mobile enclosures, but the next question that we have is from Samisa in Albuquerque, or at least if the last name is Albuquerque, I apologize. What is the standard for the XML mapping data? Let's see.
So the XML is, in this particular case, is mapped along with the ASN.1. So the schema definition defines the ASN.1. So the XML is just an intermediate format which is used to validate the map that's been generated by the tool, and that information is then becomes an input for the message builder, which message builder, it takes that message and converts into ASN.1 format. So it becomes much more compact. Each message is less than 1,500 bytes. So what Larry just indicated, if it's a large segment of a construction zone which cannot be mapped with using 1,500 bytes, then it can segment them into multiple segments. And one of the example I can say that on I-35, that what TTI used, Bob Ridier's project, it was divided into 3 segments of the message because it was close to 8-mile long mapping of I-35 construction zone.
Great. Thank you so much, Jay. The question specifically for Bob from Blaine Leonard. You mentioned using Denso OBUs, but then you said you branched out to multiple RSU and OBU vendors. Which ones did you use, and were they generally compatible?
I'm not sure I really want to get into all of the particular names. I would say that we did use multiple ones, and generally we found problems with all aspects of them. They generally were not compatible. Some did their jobs better than others. That's part of what I alluded to in my slides, where the equipment base for these operations, for these types of technologies, is still hardly evolving, and including specifications and adherence to specifications. And I don't want to malign any particular company, one way or the other right now. They all had problems to some extent.
Got it. You might get a follow-up from Blaine, as I know he's very interested in looking at the multiple RSU and OBU vendors consistently. Tony, you did ask the next question, which is the code you are using to translate between the RSM and Work Zone Data Exchange message available? It might be worth, if someone has an idea what you're referring to for RSM, or maybe the RSU is what Tony is asking. Is this a Todd question, or
Patrick? Let me answer. For our project, we took the JSON that we developed, and when we decode the message, we generated a set of JSON that we passed to Oz Engineering, who runs the Aries project. I believe that code will be available. Our intention is to make the whole project code open source and available. Some of the details we're not able to make available yet, but we hope to in the near future.
Got it. The next question is, are you currently... Oh, yeah.
Yeah, maybe this was the next question, but I just wanted to say the Work Zone Data Exchange is currently being migrated to GeoJSON format. for the V2 release. So that's if information is generated in another format, there would be a data translation step between that and what would eventually go into the WorkZone data exchange feed. So just a consideration.
Great. One other question came in for, are you currently supporting TIM messages over the RSU? And I believe this is more the traveler information messages. Any of you guys kind of doing that over the RSU?
Well, we can. We're using the road safety message in place of the TIM, but there's no reason you couldn't overlay a TIM message with other information in the work zone. But the road safety message, Jay's done a great job of having the speed changes and lane closures and things there. So but there's no reason you couldn't broadcast both.
Right. As a matter of fact, the RSM includes TIM message, which was originally under SAE J2735, is now moved to the RSM. So RSM includes work zone message as well as the TIM message and other applications also.
That is great clarification, because I was bouncing that around my head and getting those acronyms mixed up. I think there might be one more question coming in, but I'll answer one of the ones that I skipped over, which is where can the PowerPoints be downloaded from? For everyone on the webinar, we will be putting the recording of the webinar along with description and bios of the speaker and also the presentations on our website within about a week or two. Given the holidays, it might just be right after Thanksgiving. And so you'll see it kind of pop up on our website in a couple of weeks. And if you subscribe to our newsletter, you'll see it when it comes out in our newsletter that we usually broadcast out to the different folks that are out there. Let me just do a quick scroll through, and a few other kind of general comments for the speakers. I'm going to ask the last couple of questions that came in, and I know we're getting close to time, but it might be worthwhile. Tony's also asking, did you find it necessary to use RTCM or some other methods to associate the longitude, latitude to an HD map? Jay, you mentioned a little bit about correction, or even Larry and Bob would know this, right?
We did not use
mapping. Yeah, go ahead, Larry.
Sorry, we did not use correction in Arizona. When we're out in a work zone, the sky is quite visible in our work zone, so we didn't need RCTM to get lane level accuracy. We were very lucky.
Ditto.
Yeah, our testing in Michigan was the same way on the freeways. Generally, there's open sky, and we did not need to use RTCM correction. But as I mentioned earlier, the U-Box receiver that we use supports a differential correction, so it automatically provides that level of correction that we need.
Got it. Another kind of specific question, how frequently should you run the software tool chain? Is it just every day, every week, or just when the work zone changes?
Well, essentially when the work zone changes, that's when you need to run that software toolchain. And once you collect the data, the software toolchain itself takes less than a couple minutes to do the entire mapping part of it. And like I mentioned earlier, that if the information from a arrow board or from a barrels come out as a GPS enabled, and that information changes, that can be incorporated into the original data that you collect, and in that case you can just run very automatically when those changes occur.
Yeah. And I'll add to that, this is Bob. So in Texas, when we were doing the low fidelity aspect of it, and we were having Lone Star generate the RSM messages as opposed to the camp software, what we did is we used the software tool chain to digitally map the roadway and had that base file available, which then got associated with the various lane closures and everything. So in that case, we only needed to rerun the mapping tool chain when the actual physical conditions on the roadway changed.
And another question that came in, I didn't want to get to the last two. When NTC IP 1218 gets approved next year, will this cause any issues with the tool chain? I don't have NTC IP 1218 readily available, but maybe you guys know off the top of your head.
I don't believe so. This tool chain is independent from the NTC IP, but I'm not completely familiar with what are the changes coming through NTC IP 1218.
Great. And then last question, how does the software toolchain mapping handle work zones mapping on arterial intersections, specifically when connected lanes have changed for the intersection? Maybe Larry, you can kind of start us off on this one. You're a little bit closer on that.
Yeah, so I mean, I understand Chuck's question. It's one that we had where you're driving along on a one-lane work zone or a two-lane work zone, and suddenly you have a left turn lane and a right turn lane, and the left lane, instead of connecting to another lane, is now connected to a work zone lane that goes a different direction. And so one thing is that we have a linear path for the work zone right now with the way the message works, in my understanding, and Jay may correct me, but not multiple paths. So we don't have the concept of connectivity right now to use. And so if we added that, we would have to add that capability. And then the other thing is this adding and dropping of lanes. You kind of right now have to declare a canvas of lanes. So let's say it's 3 lanes all the time, even though it's just 1, so that I can add left and rights. And that might work, but I think that we can enhance the lane part of this in the future. I think we're off to a great start, and Jade deserves an enormous amount of credit for the quality of the tool. But those are issues in using it on arterials.
Yeah. I want to thank all the speakers, Dean, Todd, Jay, Bob, and Larry, and of course Colin, who is with us in spirit. This tool is definitely available. It's available for everyone to start using and just giving feedback. One of the best ways that we can really increase the rate at which we transition from the paper and pen to digital is to share information. So join me in thanking the speakers one last time, and with that, you'll get a notice when the webinar recording is available. And thank you so much for staying with us for a few minutes after the time, and join us for our next webinar, and have a great weekend, everyone. Bye.
Thank you.
Bye. Thanks.
Thanks. Bye.
Thanks, Patrick.